Today I'm going to be giving a little introduction to derivatives, and in this presentation I'll cover what the definition of a derivative is, the application of derivatives in calculus, and rules and examples. So getting us started with what is a derivative? Simply put, derivative is the exact rate at which one quantity changes with respect to another. And geometrically, the derivative is the slope of a curve at a given point on the curve. And it can also be called referred to as an instantaneous rate of change, and the derivative of a function represents an infinitely small change in the function with respect to one of its variables. And it's written as dy over dx, or given a function f, the derivative of f is written as f prime, which is what the little apostrophe that I have over here means. It means f prime. It's just another way to say the derivative of f. And a little note, dy over dx does not mean dy divided by dx. Dy and dx mean the change in y and the change in x. So dy over dx means the change in y with respect to the change in x. It does not mean dy divided by dx. So similarly, dx does not mean d times x. Like I said, it means the change in x. And dy does not mean d times y. It just means the change in y. So what are some ways that we can use this in calculus classes? Like I have a graph of a curve up here. What we can do using derivatives is look at a point on this curve, such as this one right here that's graphed, and we can find a tangent to the curve at that point, and find through the use of derivatives we can find the slope of what that curve, the slope of that tangent line. And another thing that we can do, we can use it to find critical points in our graphs of curves, such as local maxima or local minimums, and we can find out whether the graph of a function is increasing or decreasing at certain intervals using derivatives. So some rules of derivatives. The first one is the power rule. So given a function x to the n could be any number, the derivative of that is n times x to the power of n minus 1. So an example I have of this, say we have a function x cubed. The derivative of x cubed would be 3x squared. So 3 is the number that we have, and 2 is n minus 1, like we talked about. And the second rule I want to talk about is the multiplication by constant rule, and that's, say we have a function f multiplied by a constant c. The derivative of that would be the same constant c multiplied by the derivative of f. So say we have the function f equals 5x cubed, and 5 is the constant and x cubed is the function that we have. The derivative of that would be 5, which is a constant, times, like we talked about with the power rule, x cubed's derivative, which is 3x squared. So simplifying this, we get 15x squared. And these are the only two rules I have time to cover for today, but we will cover more in our next presentation.